Hi, this is Walt Boyes. I'm the editor and publisher of the Industrial Automation and Process Control Insider. And this is the Insider interview for the month of October. With me today is Joe Weiss, cybersecurity OG. He's managing director of ISA 99, the Cybersecurity Standard Committee. He is a life fellow of ISA and a member of IEEE. Joe, welcome.
Well, thank you for having me. By the way, I'm a senior member for IEEE, but that's okay.
Oh, good. You were a nuclear engineer. You were a power engineer. How did you get interested in cybersecurity?
Well, our our association goes back maybe 30 years. And when we were initially talking, I was at the Electric Power Research Institute, and I was running the fossil plant instrumentation and controls programs. And this is in the 95 timeframe. I had the head of IT at EPRI come into my office and ask me to address cybersecurity. And I asked him, why do we care about email? And I said, impacting, because that's what we thought cyber was. Well, fast forward to the 98 timeframe, and I was having, actually 97, 98, I was having colleagues of mine from all over complain that IBM was crawling all through their facilities and they couldn't spell the word pneumatic. And that became the genesis of the Y2K embedded systems program. Well, that was actually the unintentional cyber issue, clocks affecting the control system. But we never thought about it that way. And when people would bring up cyber, we said, that's not what we're doing. Okay. Now, what happened there, because it's leading to the question you asked, there were several legal issues that had popped up. One was that there were actual congressional requirements or laws that had been put together that basically said officers and directors were going to be personally liable for Y2K, not corporately, personally. And what that meant was, for the first time ever, all of the silos everywhere came down. Guess what happens when you're personally liable? So we had participation from everywhere. And like I say, silos gone. We mistakenly thought that when this ended at 12:01 on January 1st, 2000, that this phenomenal information sharing would keep going. That is why we started the control system cyber program at EPRI. It was not because we thought there was a problem. We didn't know there was. What we had was the ultimate in information sharing that we didn't want to have go away. Now, what happened then is I started going to all of these cybersecurity meetings and conferences, and I would perpetually be the only engineer there. And I would ask at the end of most of the meetings, well, what about control systems? Because everything you're talking about either doesn't apply or will hurt us. And every single time the answer was, nobody's ever asked. And
well, you've been asking now for almost 20 years.
Almost 24 years. Okay.
So have we had some successes? What successes have we had in
really
increasing cybersecurity in OT cyber?
Okay. The first is, prior to starting the program and prior to NERC, North American Electric Reliability Corporation, starting the critical infrastructure protection standards, nobody on quote unquote the operational or control system side had really heard of cybersecurity.
Mm-hmm.
So the plus is now cybersecurity is heard all over. Okay. Another plus was prior to, say, about 5 to 10 years ago, maybe even 7 or 8 years ago, there was no monitoring of control system networks for cyber.
Mm-hmm.
We now have all kinds of companies that do that. So those are the two pluses. Now, there are a whole bunch of unbelievably large minuses that in
That was
many
my next
senses,
question.
yeah, that have actually shoved us behind where we were in 2000. The first is culture. IT, and now Gartner's the one who came up with the term OT.
Mm-hmm.
Right? And in all due respect, what OT really is are really the control system networks.
Mm-hmm.
OT is not a turbine, it's not a transformer, it's not a pump or a valve. And OT, it's if you talk to engineers and ask them if they're OT, they're going to ask you, what is it? What did you just ask?
Mm-hmm.
OT is very much a cybersecurity term. What has happened is the culture wars between the engineering / operational organizations and the IT and network security organizations have exponentially increased. They are now almost completely independent of each other. And they don't
Mm-hmm.
like each other. Okay.
They never did.
They never did, and it's worse now. So when you're asking, now, what you'll have is all of these OT people saying, well, OT is working with IT. No, it's network security people working with other network security people. It isn't the engineers and technicians who are working with them. They're out, they've been kept out of the loop.
Mm-hmm.
Okay. So culturally, it's broken. And by the way, if you don't fix the culture, it is impossible to be secure. Period.
Mm-hmm.
So all of this stuff about how secure people are completely wrong. The other thing is, you had asked, the technologies that are being developed, I'm saying in the 95%, okay, there's always a couple that aren't, but almost all of the cybersecurity monitor and technologies being developed or employed are only for looking at the internet protocol networks.
Mm-hmm.
They're not looking at serial networks, point-to-point networks. They're not looking at the field devices, the sensors, actuators, drives, the quote unquote, the tools, the calibrators, or anything else.
Mm-hmm.
All of that is still as if we're still in 2000. Okay. So
Yeah, and
now,
in the old days they said, well, a smart instrument isn't really smart. It's maybe got 8K of memory and blah blah blah. Well, I sold a company to Schneider 4 years ago, who was making transmitters with 64 gig of RAM. And you tell me that can't be hacked or wouldn't be a target.
well, here's the thing too. You have two groups involved in security. You have defenders and you have the offensive or attacker side. Everything we've been talking about are the defenders.
Mm-hmm.
The defenders have a scope of which they're going to defend. And if it's outside that scope, it doesn't count.
Mm-hmm.
Walt, you remember what happened when way back when the Siemens International User Group had their meeting with the Siemens controllers, back in 2008.
Hmm.
And they identified all of these vulnerabilities, and the defenders walked out of the room having no clue what any of it meant.
And what they had done was identify the vulnerabilities that allowed Stuxnet.
Correct. That is still there to this day.
Yeah.
To this day. Okay.
I was in the room. I know. I was there.
Now, on the other
So
side, let me just finish this.
go ahead.
On the other side are the offensive people. The offensive people are not limited to an org chart. They're not limited to a quote unquote scope.
Hmm.
And they go about life by saying, what do I want to do? And how do I need to get there? The defenders are severely limited. I mean, two things come to mind. Number one is 9/11. Number two, what happened in Israel. In both cases, what happened? A severe lack of imagination. Okay.
Okay, unpack that. How do you mean that in cybersecurity terms?
That the defenders only look at what can be done to a internet protocol network. They have no imagination, like what you just said, Walt, what using the sensor,
Hmm.
which is totally, here's the point too. All of these requirements being put together in the government are all based on internet protocol systems and internet protocol system capabilities.
Hmm.
So what do they have? They have, for example, multi-factor authentication. Well, that's
Hmm.
okay, but you have sensors that have no capability for any authentication.
Right.
You have requirements for strong passwords being changed frequently. Our devices can't even take a simple password. You have the concept of zero trust. Every field device is 100% trust. Period.
And it's obvious that it shouldn't be.
What? Oh, no. It has to be.
Okay.
The point being that temperature sensor that's continuously monitoring temperature is feeding that controller in real time constantly.
Right.
Okay. There is nothing there to say, wait a minute, is this really coming from the sensor? Is this coming from Beijing? Do I really trust this or that?
Yeah.
Our equipment today simply doesn't have any of that in it. 5 or 10 years from now, when they build field devices that are secure from the very inception all the way down to the chip level, at that point in time, maybe zero trust has some, meaning. Today, it's totally and completely irrelevant. Yet, people coming in from, I hate to say it, IT or OT, that's their whole focus. I mean, even for example, with IoT and IIoT, where are they playing? That IoT gateway.
Hmm.
They're not asking anything about the actual sensor or
No, because
sensor
the
network.
sensors are stupid. They just report wrong.
Well,
Now,
you
what
know,
industry verticals are doing the best jobs, if any, and which are lagging, in your
well,
opinion?
number one, it was I'm going back in history a little bit, and things have changed. When I first got involved at EPRI, this is in 2000, it turns out the gas industry was doing, SCADA encryption. I mean, natural
Mhm.
gas was way out there. Well, guess what? It fell totally off the face of the earth in terms of cyber. Water's never really been there. Electric has been hijacked, I'm sorry for using that term, by NERC and the SIP standards, which makes them unbelievably vulnerable and unbelievably short-sighted. I'd say oil, gas, chemicals are by far the furthest ahead, with the exception that they're completely dependent on control system field devices,
Mhm.
which have no security or authentication in them, or forensics. You've got coming up, API, the American Petroleum Institute, has their big cybersecurity conference.
Mhm.
Other than when I gave some training there a couple years ago, and people even said, "Oh my God, we wish we'd have had our engineers there." Anything but "quote unquote" traditional network security has not been on their table.
Mhm.
I put in a couple, over the years, abstracts on sensors, actual, all of this stuff, not been accepted.
No, and I've seen some comments from people who are saying that um that you're barking up the wrong tree, if it's a tree at all, about sensors being um unsafe. And I can't agree with that. I think you're dead right on. Uh
Well,
sensors sensors have to have some way of authenticating themselves and preventing intrusion. And to my knowledge, virtually none, if not any, have.
no, that's correct. And I'll give you a couple of other points. And everything I'm telling you is unclassified. There's nothing I'm telling you that, people may not know it, but that's not because it's classified. It's just because they don't know where to look or who to talk to.
Mm-hmm.
Okay. Sensors have been targeted literally since Stuxnet. Okay.
Mm-hmm.
You know, part of the attack mechanism was the sensors.
Yes.
Okay. The Russians needed to attack that for Triton to be successful. The Chinese are looking to do that as we speak in what they're doing with equipment they build and
Mm-hmm.
sell to us. Okay. I go back to, this isn't in IT's quote unquote purview, therefore it doesn't count. I gave a
Well, it
presentation.
doesn't. It isn't going to count until somebody blows up a major refinery, and the blame is laid on bad cybersecurity practice.
Well, or the lights go out, etc. But the bottom line is that, people have said forever, wait until something bad happens and then we'll do something. Lots of bad things have already happened. But here's the difference too. In IT, it's cyber. You may not see it right away, but it's cyber.
Mm-hmm.
In the control system world, you can't hide when something bad happens. A refinery blows up, a train crashes, a plane crashes, the lights go out. What you don't know is if it were cyber related,
Mm-hmm.
which brings up what I just completed and got approved literally this past Thursday, which would have been what, the 12th, okay?
Mm-hmm.
I wrote a micro learning module for ISA on identifying control system cyber incidents. It, like I say, just got approved 3 or 4 days ago. It's now public.
Mm-hmm.
Don't have to be an ISA 99 member, don't even have to be an ISA member. I will
Is that the first time anybody has written a rubric for identifying cyber incidents?
Yes. And by
That's
the way,
pretty important.
it was not, I know I'm going in dirty laundry time. It was not unanimously approved.
Well, the fact is that it was approved, and that's better than it used to be.
Yes. Now, I will have a blog out on that, hopefully tomorrow or Wednesday. Okay.
Okay. And your blog is on controlglobal.com.
Yes, unfettered. Now, again, ironically, part of the limitation of keeping it on unfettered, which by the way, Walt, you're the reason it was on unfettered to start with, was you have other magazines who won't address anything I do because they think I work for Putman, because that blog is on unfettered.
Yeah, or in what do they call it now? Endeavor Business Media.
Endeavor. But the point being,
yeah,
they feel like, well, they can't put it out because I did. Now, let me also give you another one. This is cyber, but not really cyber. Last February, there was a project done at a $1 billion manufacturing facility. It was not for cybersecurity, it was for productivity. Okay.
mm-hmm.
And the reason they did it was because the Windows display said everything was good, but the plant staff was uncomfortable. They just thought this facility wasn't as productive as it should have been. Now, notice I never used the word cyber.
Mm-hmm.
So they decided to do a quote unquote one-off test.
Mm-hmm.
And they took one of their manufacturing lines that had 16 sensors: pressure, temperature, flow, motor amperage, vibration, and valve position.
Okay.
That's the entire world. There's nothing unique about what I just brought up. Nothing.
No.
Okay. And
mm-hmm.
also, if you think about that, those sensors are have to come from different companies.
Mm-hmm.
Okay. These are not something, well, this is all from the same batch or whatever. Okay. And what they did is decided to do an independent check of what was going on. And I'm not naming names of companies. So they decided to use a technology that would look at the 4 to 20 milliamp current values of the sensors. In other words, the physics of the sensor.
Mm-hmm.
And then use machine learning. So they're basically saying, let's take a look at the physics and compare it to what Windows is telling us. Okay. Well,
mm-hmm.
the first thing they found that blew everybody's mind was more than half of those sensors were either inoperable or out of calibration, and the Windows HMI didn't show it.
What was the Windows HMI showing?
Again, it was showing that there was lots of sensor readings and they all seemed whatever, and so nobody questioned.
So where were those sensor readings coming from?
Well, the point being that when the HMIs didn't get certain sensor readings, it didn't stop anything.
It made them up.
Either that or it just wasn't there, and then people were seeing enough sensor readings, everybody was fine. Okay. Now,
okay.
the second thing they did is the main feed pumps were what was most critical for productivity. Well, Windows said everything was fine. When they started looking at the raw sensor data, what they found were the pumps were having real problems, but on the orders of seconds to less than a minute. Guess what? It's too fast for Windows to see anything.
Mm-hmm.
Well, then they did one other. And by the way, everything I'm telling you is an article we put out. It's in the November 2022 issue of IEEE Computer Magazine. And one of the co-authors is from the Naval Postgraduate School. Okay.
Mm-hmm.
But here's what we did. It was a very, very, very detailed cost impact analysis, first time ever. And what they found was there was a 3% hit on net productivity in this billion-dollar facility. Now, one of the other things behind this was the
I'm
reason.
stunned.
Pardon?
3%
3% hit on
decrease.
net productivity in a billion-dollar facility.
That's a lot of hundreds of thousands of dollars.
Yes, it is. That's why this is in IEEE Computer Magazine. We've now got a dollar value on what this is costing us just every day. Not insurance, every day. Or what the actual real ROI is. And the other point is, cyber comes along for the ride. Now,
Okay.
here's
How do you
the
mean
other
that?
point. Remember the culture problem.
Mm-hmm.
This was a productivity project. It had buy-in from corporate, from plant management, from operational staff. And oh, by the way, the cyber people were there.
Mm-hmm.
But it worked because it was not a cybersecurity project. If it would have been, you would have had no participation from any of the engineering or operations people. Isn't that a damning statement?
Yeah, it is. So, what are the most important things that we should be doing to keep our infrastructure safe that we're not doing?
Well, number one, you got to say our infrastructures are engineering systems. Yes, you talk about cars being computers with wheels. They're still physical systems. You have to address the physical systems. They may be, say, electric cars, but they have electric motors. They're not just networks. Okay.
Yeah, that old phrase that never quite caught on, cyber physical systems.
Well, this is the problem we have, Walt, is exactly what you said is our problem. These are not cyber physical systems. These are physical cyber systems. A motor is not a cyber system. It is a physical system that happens to have cyber connections. When you say it's cyber physical, you know what you're doing? You're saying, hey, cyber people, you need to be the lead. Wrong, 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 and wrong. These are.
Who should be the lead? The engineers?
Yes, it's the engineering systems.
Okay.
Before cyber came around, we would have never, ever been having these discussions. It's an engineering system. It's the engineer's problem.
Mm-hmm.
And if they had an issue, they go talk to whoever they need to fix it. Well, you broke this. You now said that a turbine is not an engineering system. Wrong. Why is cyber there in the lead? They should have never, ever in a million years been in the lead. Their support. That's why it's funny, that whole term. And when I tried telling that to NIST, they didn't want to listen. The term of art is cyber physical. It is not. A motor is not a cyber system. It has never been and never will be. It's a physical system that has cyber connectivity.
That makes a lot of sense. Much
And
more than I've heard before. So what other things should we be doing besides turning physical things to the engineers?
well, if you make it, the whole point is, if you make it an engineering issue with network support, it's not saying don't have the network people, have them there, but supporting, not leading, supporting. The CISO should never, ever, ever, ever be responsible for this. Vice President of Engineering, Operations, call it what you will. It's their equipment. The CISO should be supporting them, not the other way around. The issue with the sensors are unique and interesting for one reason. Everything starts from the sensor.
Yeah, that's the physical connection to the real world.
Yeah, that's your fingers, eyes, ears, nose that goes to the brain. Okay. If you know the sensors are right, that is productivity, it is safety, it is, if you will, maintenance, predictive maintenance. It's, like I say, it's secure. It's all of these. What we've done is, in the world of cyber, what they've all done is made the assumption, and when I say all, I mean all. They've made the assumption, actually, I shouldn't have said that, it's 90 whatever percent. They made the assumption that the sensors are uncompromised, authenticated, and correct. And so where they start is with that serial to Ethernet connection. In other words, as what they do is pick it up as soon as it becomes an Ethernet packet. They ignore
And
everything.
they call that the edge.
Yeah, but the edge isn't. See, that's an IT verb of the edge. The IT verb is that that gateway. For us, the edge is the sensor and the actuator.
Which might not even be on the plant site.
Well, the sensor or the actuator will be, but that gateway may not be.
It could be a pipeline.
Yeah, but I'm just saying the sensor or the actuator is at the point of concern.
Right.
The gateway could be, depending
wherever
on how it's configured, could be next, right physically next to it, or it can be miles away.
Sure. So what are the most important trends that we should watch going forward in cybersecurity?
Well, what we should be watching for is, number one, are engineers being trained in cybersecurity? And in general, the answer is no. Again, I Venn diagram from a long time ago. It's in the book. My book was 2010. Okay. And that is, cybersecurity is taught in computer science. There is no requirement in most universities that anybody taking computer science has to take an introduction to engineering course. None.
Oh, but they sure as hell should be.
No. You asked, where should we be? Okay.
Yeah.
Number two, engineering is taught in the disciplines: nuclear engineering, chemical engineering, industrial engineering, chemical engineering. Okay. Most of those, they never say never, never say always, most of those have no requirement have to take an introduction to cybersecurity course. So
Mhm.
what is happening is, from day one, these two cultures are taught implicitly not to work with each other.
Mhm.
Okay. It's broken completely. Okay. It has to be fixed. I mean, the bottom line is the power grid is not a data network, no matter what anybody says.
Mhm.
You know, a factory is not a data network. A refinery is not a data network. Do all of them use data? Yes. Can all of those function without those data networks? Yes. They did for 100 years.
That's right.
But
They
they
functioned
cannot.
without loop control.
Yeah, they cannot function if a valve doesn't work, or if a motor's not working, or if
Mhm.
a protective relay is not acting properly. It
Right.
won't work no matter.
Right.
The only one that's really, really stuck, I shouldn't say the only one, but one of them that is really stuck is pharmaceuticals.
Mhm.
Because in order to meet all of the, if you will, documentation requirements, they gotta have that IT network as well as the control network.
Right.
In a funny sense, not necessary for the production of the drugs, but without having the paper, it can't go anywhere.
Right.
But can you run a refinery without any OT network? The answer is yes. Will it be very efficient? No. That's why you put the OT networks in. But can you run it? Yes. Can you run
Sure.
a power plant? Without it? Absolutely you can. Can you run a
You
grid
can
without it? The Ukrainians
you
did.
can run a water plant. You can run a water system or a
100%.
wastewater system.
The issue is the IT and OT network people have basically, I keep using the word hijack, which is a bad term, but it's a realistic term. They've
Mhm.
hijacked the discussion as if it's impossible to do it without them being there. That's not true. It's impossible to do it in a highly efficient manner, but not impossible to run. Go
Y-
back to Y2K. What was everybody? We were trying to find all of these gray hairs to be able to manually run the facilities on the in case.
Right.
Well, that's okay, because that's assuming the sensors and actuators and drives are all right. If they're
Mhm.
not, you can't run that facility, period.
So do you have any last comments for us as we wind this up?
Yeah, you and I'm not trying to sound bleak. Like I say, that what I told you about that IEEE paper and what we did, we showed there is real light at the end of the tunnel, and it's not a train. This is improved cybersecurity, productivity, reliability, safety, predictive maintenance. All of those come. It just won't come if you keep wanting to do the things we're doing now. It doesn't work. And so it's just like I say, the deja vu thing. Well, we were talking about this in the mid 90s.
Yep. Yep.
But thanks to all of these, whiz bang network types, it's driven it totally away from where we were trying to be. And the last point I wanted to get across is this. The network people keep making all of these noises about OT and control systems and how insecure they are. think about things like solar winds and everything else. You know, the networks, despite all of their technology, are still being compromised daily.
Mm-hmm.
Look at ransomware and everything else. We, on the engineering side, have the capability of separating ourselves and being able to live independent of all of that, and doing so literally in an improved way. But that's going to require people to recognize you got to make a change.
Mm-hmm.
That's not happening. Who's at the table? The people at the table are the people who are doing everything they can to keep us going in the direction we're going. All about monitoring OT networks, doing all of this threat detection, all the rest of this. Any of which has anything to do with the actual devices in a control system or in a facility.
Mm-hmm. Well, we'll see. Hopefully things will improve. We've only been beating on them for 20 years with sticks. Maybe we need to beat harder.
Well, what we need, I'll leave you with this. We can't win. The engineering world cannot win. The only world that can win is the money world. The credit rating agencies have to come in and say, we won't accept this risk. The insurance companies have to come in and say, we're going to hammer you on your, your premiums, or we're simply not going to insure you.
Mm-hmm.
We have an answer for them both. But they're the only ones that are going to be able to walk into the C-suite and say, you need to listen to us, or you're not going to like what we're going to do to you.
Right.
And
right.
That's
You
where
and I
I'm
had a conversation, it's got to be at least 15 years ago, about the way this is going to go is the insurance companies are finally going to put their foot down and say, do it right. And I
That's where
still
I'm
believe
working,
that.
because until they do this, the OT network world is going to continue pushing us down this road to abyss. Now, they have things that can help, okay?
Mm-hmm.
They're a necessary part of the solution. They are simply not a sufficient part. And until they get over that they can't do it themselves, we're in trouble.
Well, I hate to leave it there, but we kind of have to. Joe, it's been great having you for this interview. And I'll be showing on the last slide Joe's contact information. And you can get a hold of him at Applied Control Solutions in Palo Alto, California.
Actually, Cupertino.
Well, okay. So I was
Close.
close. I haven't lived in the Bay Area in 30 years. So
Yeah.
thank you very much, Joe. I appreciate the time that you've talked with us.